The IP address is one of the cornerstones of networking. It defines the computer or host you're working on. Nowadays, every computer and many other devices have one. This address allows each computer to send and receive information back and forth in an orderly and efficient manner. An IP address is kind of like your home address. While your home address identifies your house number and the street you live on, an IP address identifies your computer number and the network it lives on. Here's an example of an IP address, 192.168.1.1, in fact a very common address. Now every IP address is broken down into those two parts we mentioned, the network portion, in this case 192.168.1, which is the network your computer is a member of, and the host portion, which is the individual number of your computer differentiating your computer from any others on the network. And in this case it's .1. If any other computers would like to communicate with yours, they'll need to be configured with the same network number. However, every computer on the same network needs to have a different host number or there'll be an IP conflict. Of course, as a talented admin, you'll learn how to avoid IP conflicts, and I'll give you some tips on how to do so throughout these labs. IP addresses are actually 32-bit dotted decimal numbers. If you were to convert an IP address's decimal numbers to binary, you would have a total of 32 bits. It's considered dotted because each number is separated by a dot. Altogether they contain 4 numbers, each of which is a byte or octet. For example, 192.168.1.1. 192 is an octet. Its binary equivalent would be 11000000, which is 8 bits. 168 is also an octet. Its binary equivalent would be 10101000, and so on. Adding all 4 octets together gives us 32 bits. When you add IP addresses into the computer, the decimal point, or dot, is used to separate each number you enter. Now, IP addresses are usually applied to your network interface card, or NIC, so let's show our first demonstration of IP addressing. We're going to go to Start, and then right-click on My Network Places and select Properties. That'll bring up the Network Connections window. From here, I want to go to my local area connection. I'll right-click and select Properties, and that'll bring up the Local Area Connection Properties window. We'll scroll down and select Internet Protocol TCP/IP, and go to Properties, and that'll bring up the Internet Protocol Properties window, where we're going to make our configuration changes. This is the default configuration for Windows clients. They obtain IP addresses automatically and obtain DNS information automatically from a multifunction device or DHCP server. But I want to configure it statically, so I'm going to select the Use the following IP address radio button, and then we'll go into the IP address field and type in our IP address, 192.168.1.1. And a quick tip, use the numeric keypad for speed. The numbers and the dot or decimal point are right in the same place. Just make sure you have the number lock key on. When we're done, we can press Tab, and that'll bring us to the next field, which is the subnet mask field. And it automatically gives us a default Class C subnet mask of 222.55.0. That's it. We're done with the IP configuration. We'll go ahead and click OK. And then you have to make sure to click Close for the Local Area Connection Properties window. That will bind the information to the network interface card. Let's talk about the subnet mask a little bit. The subnet mask is another 32-bit dotted decimal number. It defines where the network portion of the IP address is and where the host portion is. For example, in this scenario, 192.168.1 are the network portion. How do I know this? The 255s tell us. All of the 255s together correspond to the network portion of the IP address. And the zeros, in this case there's only one, correspond with the host portion of the IP address. So you can look at any IP configuration and the subnet mask will tell you what network the computer is on. More on subnet masks a little later in this lab. Gateway and DNS addresses. The gateway address is necessary if you want to communicate with computers on other networks. It acts as a portal to other networks like the Internet. The gateway address is usually on the same network number as your computer. The DNS server address is necessary to facilitate connecting to websites like www.comptia.org. It translates the name of the website you type to that computer's corresponding IP address. You see, computers ultimately communicate by IP address, not by their name. But names like comptia.org or Microsoft.com are easier for users to remember than IP addresses. Of course, as a network admin, you'll probably memorize lots of IP addresses when the time comes. Let's show an example of these now. I'm going to go back to the IP properties window where I've already configured my IP address and subnet mask, and I want to configure the gateway, so I'll click in the default gateway field and I'll type in the address of the gateway, which is 192.168.1.100. That's my multifunction device that allows me access out to the internet. Next, I want to specify a preferred DNS server, and I'll type that in now, 151.198.0.38. That server in this case is out on the ISP, and my internet service provider runs that DNS server. But it could be that your DNS server is on your LAN. It all depends on your network setup. You'll notice that this DNS server is on a different network number than my IP address, which is okay. Usually though, the gateway will be on the same network number as your IP address. ipconfig and ping. You can see your IP configuration by typing the command ipconfig in the command line. Let's show a demonstration of this. I like to open the command line from the run prompt, and you can get to that by going to Start and then Run, or by pressing the Windows and R keys at the same time. That'll bring us to the run prompt, and we just type CMD and press Enter, and that'll open up the command line. From here we can run commands like ipconfig and press Enter, and that'll give us some basic information about our network adapter, including IP address, subnet mask, and default gateway. Now, if you want additional information like DNS server addresses or MAC addresses, you'll have to use the ipconfig command with the /all parameter or switch. To test if your computer can connect to other systems on the network, use the ping commands. So for example, we could go back to the command line and run a ping to our multifunction device, which is 192.168.1.100. When I press Enter, we get 4 replies by default. So we know that that device is alive. Any other type of message, and we'd know we'd have some type of issue that we want to troubleshoot. We'll cover these and other commands in more depth during Lab 15, and you'll find that using the keyboard to manipulate the CLI, or the command line interface, can be much faster than working with the corresponding GUI-based applications. I'd like to take a moment to talk about IP classes. To organize the IP scheme and facilitate the allotment of IP addresses, IP classes were developed. What you're looking at here are the 3 main classes you need to know for the exam. And what you want to do is you want to look at your IP address's first octet. The first octet will define what class IP address it is. Let's look at the classes. Class A ranges between 1 and 126, and it's used by government, large corporations, and internet service providers. Class B ranges between 128 and 191, used by mid to large companies, universities, and other ISPs. And Class C is between 192 and 223, used by small companies and home offices. Now, an IP address like 10.0.0.1 would be a Class A address, because the first octet 10 falls into that Class A range. You'll notice that 127 is not listed. That's because it's considered the loopback address used for testing. And there are 2 other classes, Class D, which is between 224 and 239, which is used for multicasting, and Class E, between 240 and 255, which was reserved for future use. Now, onto default subnet masks. For each IP class, there is a default subnet mask. For example, Class A IP addresses use 255.0.0.0 by default. Class B addresses use 255.255.0.0, and Class C addresses use 255.0. Now, you may see other types of subnet mask configurations in the future, Keep in mind that these are the default subnet masks for Class A, B, and C. Class A IP configuration. Now that we know a little more about IP, let's show another configuration, and this time a Class A setup. This documentation is designed to give information about the network we're going to create. On the bottom right-hand side, it tells us this is a Class A network and that the network number is 10.0.0.0. Network numbers always end in 0, and you can't use that address for a host. It's considered the entire network. The subnet mask is 255.0.0.0, and that's going to be used by all the hosts. We have 3 hosts. There's a D-Link multifunction device on the upper right-hand side, which I'll configure as 10.0.0.1. And we have a laptop on the bottom left, which is 10.0.0.2, and a server, which we'll be using later, 10.0.0.3. By the way, IP addresses are configured the same way on Windows servers as they are on Windows clients. So first, let's configure the D-Link multifunction device. To do that, I'm going to go to my browser, and I'm going to type in the IP address of that router, which is 192.168.1.100. We'll log in, and we'll go to the network settings, and we'll modify the IP address. And we'll change that router IP address from the current Class C address to what we want, which is on the documentation, 10.0.0.1. And we'll modify the subnet mask to Class A 255.0.0.0. We'll save those settings, and we'll reboot the router. I'm going to lose my connection to the router temporarily until I configure the laptop. So let's do that now. We're going to go to our network connections, and we're going to right click and go to properties and go back to that IP properties window. I'm going to modify this and remove this old Class C address and put in the correct .2 Class A address, and we'll modify the subnet mask 255.0.0.0, and we'll modify the gateway. By the way, if you want to back out information out of a field, you can press the End key on the keyboard and then hold down the backspace, and that'll remove all that information, or you can just overwrite it. Default gateway is the multifunction device, that's 10.0.0.1, and we'll leave the DNS server as is. We'll click OK and close. That'll bind the information to the network adapter. And the best piece of advice that I can give you is to test. Whenever you set up anything, whenever you configure anything in networking, test it. So we're going to go to the command line, and we're going to try to connect to the multifunction device. We'll do that by running the ping command and typing the IP address of the multifunction device. We get replies, so it looks good. And the Class A network is now set up.